Here we're getting into one of my favorite ideas in math, and it deals with the number 0. 0 is such a cool concept, but sometimes it's a misunderstood concept because we just haven't given it much thought. So when we're using zeros and they pop up in exponents, what does that mean? Well, anything to the 0 exponent, to the 0 power, turns that entire base into 1. So for example, 7 to the 0, its base is a 7 to begin with. To evaluate that, that just becomes a 1. So 7 to the 0 power is 1. 13 to the 0 power is 1. X to the 0 power is 1. Negative 14 to the 0 power is 1. And there's a great visual concept I can show you later to kind of make sense of that so you have a visual idea as well. Let's look at negative 5 to the 0. Well, that 0 exponent turns the entire base into a 1. And in here, the base is the entire negative 5. So negative 5 to the 0 is a 1. The next problem I have is negative 5 to the 0. A little bit different than the problem before that. And what's different is there's no parenthesis which slightly adjusts what its base is. Here its base is just the 5, not the negative. So I have negative, and 5 to the 0 is a 1. See that slight difference? The next problem I have is 10x to the 0. What do you think the result of that is going to be? Well, if you were able to identify that the base was only the x, then you know it's going to be resulting in 10 times the 1. 10 times x to the 0, which is a 1, or just a 10. And then on that last example, you can start to see a little bit of the subtle difference. This time, the entire 10x is to the 0 power. So 10x to the 0, and that just results in a 1. It's the same rule. It's applied the same all the way across. The hard part is don't be confused in what its base is. Understand its base. And those parentheses will help us determine what is the base to the exponent and what is not. Because it's only the base that is affected by the exponent.